Today we are going to continue with section 11.7, graphs of polar equations. Now your book actually covers 11.6 and 11.7 together, and I prefer to separate into two sections. Actually, I prefer to separate in three different sections. They cover way too much in one section. So we continue to label this one 11.7, even though in your book will be 11.6. Now let's go and revisit what we covered on 11.7 so far. We know how to graph polar graphs, and now we know how to graph them using just a table of values, just like we did in Algebra 1, correct? In Algebra 1, we learned how to plot points. 0 degrees is 3, 15 degrees is 2.9, and then we just connected, same thing on Algebra 1, graph points, and then connected them with a straight line. And I know that some of you guys found this very tedious, because in that you needed to go through the process, and even you saw me going through the entire process on your notes. Minus 3 sine of 15 degrees, and I had to make sure that it was on degrees if I was going to use degrees. Or some of you guys actually did something. You went into your graphing calculator, y, and you type in 1 minus 3 sine of theta, which is here. We're going to label as x. And then you just went into your table. You can look for the values, but then you also remember that you can also go into your table settings. So second, table settings. And you can say, no, I'm just going to have it, I can ask me for the values that I want. So therefore, if now that I have it under ask for an independent variable, then I can say, for 0, then for 15, then for 30, then for 45, what's 45, and 6, and then you also find it to be a little tedious as well. So some of you guys say, actually, I know that I can do the table settings, and I can just say, I'm going to do auto. And I want to say I must start at 0, and table settings, and then I'll go back to table. And I want to be able to set this column to be every 15. So I'll go back to table settings. I want to start 0, but I want to go every 15 degrees. I want to make sure that's under auto and auto as well for the independent and dependent variables. And now once I go into the table, then I can just go and write down all those values. So some of you guys did it this way as well, which is great, but then still a little tedious because you need to be able to plot every single point. Now, some of you guys actually probably use Desmos, and you just typed in the equation y equal to 1 minus 3 sine of x. And I'm going to place as you see table values. This is my x, and this is my y. And then you just type in a 0. And sometimes this doesn't come up, so I usually change this to y1. Makes it a little easier. And then the values appear. Then I do 15, 30, 45. And then it also does it for me. Then I just write them down. All the way down to 360. So if you did, that was fine. I didn't show it this way because I want you guys to realize how tedious it is to be able to plot points one by one by one. Well, actually not by one, right? Because we can actually done 0, 1, 2, 3, all the way to 360. So today we're actually going to graph using a different method. So now that we know how to plot points and we know how to graph equations, polar equations using points, now there's some way that you can actually, in graphing a line, you can do the slope and the y-intercept. We're going to do the same thing. Let's go to the example first, and then I'll come back to this. And if you have Desmos, you might want to do it with me afterwards, or just try yourself. Just make sure that you can get rid of this. There you go. So the method that we're going to use, we are going to actually just go back to graphing this on an x and y axis. this equation. So I'm going to graph y equals 3 the sine of x, and we're going to go from 0 all the way up to 2 pi. So be in the interval from 0 all the way to 2 pi. So if you can go back to your notes on graphing sine and cosine, that will be very helpful. So I'll make a x and y axis. I'm going to make a longer x-axis, and my y-axis I just want from 0 to 2 pi, and we can do from 0 to 360 if we do it in degrees. For now, we're going to switch over to radians, because once you go into calculus, you'll be using mostly radians. So we need to be able to label your x-axis. So be 0, and 1, 2, 3, 4 will be, every 4 will be pi. 1, 2, 3, 4 will be 2 pi. Now, do you guys remember what your period is? So let's go and go over to the left and just kind of go over the same concepts that we learned. We know that the 3 will be your, correct, will be your amplitude. Will be 3. And we know that means there's going to go, there's no plus or minus, so therefore we're going to go up all the way up to 3, all the way down to negative 3. Then what else is next? There's no phase shift, but we need to be able to find our period. Do you guys remember your formula for your period? For sine and cosine, secant and cosecant, your period is 2 pi over b. And what is the value of b in this case? B is just coefficient of 1. So therefore it will be 2 pi over 1, which is 2 pi. That means that your sine curve, an entire rotation, will be from 0 all the way up to 2 pi. So it's not being shifted, there's no phase shift left to right, it's not being shifted up or down. We know your amplitude is 3, so it's going to go all the way up to 3, all the way down to negative 3, your period is 2 pi. Now, what is next to be able to graph? Correct. We're going to divide this in 4 sections. And you need to remember, sine starts at 0 or at 1. Correct. Sine starts at 0. So 0, then I'm going to go all the way up to 3, then back to 0, back to negative 3, or down to negative 3, and then back to 0. Then I'll place my rotation. So make sure you make a curve. Missing it. And make sure I curve it. So that is the curve of sine. So what we're going to do, we're going to translate that over here. And that will make it much easier. And you'll be a little, because you want to be able to understand what happens as we translate to 2 theta and what happens as we have a 1. And the graph is going to be very helpful. And in algebra, in calculus, you're going to have to be able to find the area under the curve of a polar graph. And I believe that's your second semester of calculus. So therefore, at 0, radians is 0. So we're going to locate your main points, 0, 0, 0, your maximum and your minimum. So at 0, 0, so I have this point here. From 0 all the way to pi, you'll be positive. So from 0 all the way to pi will be positive. That means that your curve will be on this part of the graph. You're not going to go to the opposite side. So 0, we're going to go to your maximum. That is pi over 2. Pi over 2 is up here. And this is, the height is 3. So therefore, at pi over 2 will be 1, 2, 3. Then we're going to go back to 0 at pi. So this is pi over 2. At pi will be back to 0. And I know at that point you say, hold on, Diaz, how does that help? Well, let's be patient. We'll get there. So now, so I know that starts here, goes up here, and then comes back over here. Do you guys agree? So now what we're going to do, we're going to find this point halfway mark, which is, because we know that that is pi over 4. So pi over 4 is here, which is about 2, according to my graph. Now, if I want to actually find the correct value for pi over 4, I can just plug it in. So I'm going to use my calculator. I want to make sure, I'm going to go back. And you can also use, if you don't have a calculator with you, you can also use your decimals. So Desmos has a nice calculator that you guys can use for this. I usually use the Desmos to graph, but this Desmos calculator, it works really well, and I use it all the time if I don't have a graphing calculator. So I can type in 3. I want to make sure that I'm on radians, the sign, and I'm going to place my fraction bar, and that'll be pi over 4. And let's see, where's my pi? Do you see? Well, let's see it before I do. Oh, it's right there. Pi over 4. So it'll be 2.1. So therefore, a pi over 4 is 2.1. So this is pi over 4. My value for the graph will be 1, 2.1. Now, if I want to be able to say 30 degrees, I can type in a pi over 3 in here, which is pi over 6, right? So it'll be 1.5. So 30 will be 1.5. I want to be able to find this point here, which is around here, should be about 2.5, 2 point something. So therefore I can say, no, pi over 3, what is the value? That'll be 2.6. 2.6. But most of the time, once you actually find this value, you say, you know, it's going to be something, a rotation, something on this part. Now we're going to get to this section, from pi over 2 all the way to pi. Well, I know that the 3 pi over 4, which is here, is going to be the same value as this part, correct? It should be symmetrical. So it'll be 2.1. And then from there I can say, okay, so I know that it's going to go from here, it's going to go around, to come back, and that is a full rotation. Well, that's from 0 all the way to pi. Now what happens on this part? From pi all the way to 2 pi. So from pi all the way to 2 pi, what happens there? Well, I know that this point here, I know that this is 3 pi over 2. So at 3 pi over 2 is going to be negative 3. So 3 pi over 2 is here. And if you guys remember that whenever it's positive, you go towards 1, 2, 3. But in this case, it's negative, so it'll be 1, 2, 3. Well, so it basically it's going to be repeated. And if I go at this location, this will be, what will be this part? This will be 5 pi over 4, 1 4, 2 fourths, 3 fourths, 4 fourths, 5 fourths, which is here. That'll be negative 2.1. So it'll be, instead of going forward, it'll be going backwards, 1, negative 2.1. So that means that the circle gets repeated once again. And that's it. That is a graph of 3 sine of theta. Now let's go into decimals and kind of explore that. R equals 3 sine of THTETA. Now I'm going to go back and change to migrate to radians. And that is the graph. Let me go and place that as red. Now, I want to see the formation of this. So I'm going to do something. I'm going to play with the domain. So this is how you place a domain on decimals. You can place a brace, or you can use your, and there's a brace somewhere over here. So you can use that. I usually prefer just to type it up. So I place my brace. I go from 0 is less than theta, which is less than, if I do 45, you see that form. If I do 90, just make sure that you have it on degrees. And now I can do 180. Notice that at 180 makes the entire shape. If I do 360, you will be able to see any change. But instead, what I'm going to do, I'm going to place A in there. Now, that's my brother there. So instead, I'm going to type in A. So that way you can actually see the formation. Now I go from, I'm going to click to 360. And now you'll be able to see the formation of the graph. And what actually I want to be able to do, I want to be able to see the point at the very end. So you don't have to type this up. I'm just going to do it myself. There'll be R. Remember to find the coordinates on your x-axis as a point on a rectangular form. Will be R cosine of theta, comma, R sine of theta. But in this case, I'm looking for the A value. I actually want to substitute this with an A. And somehow R is this value 3 sine of theta. So I'm going to actually place it as B equals 3 sine of A. So it actually moves, and I'll change this to an A. And now you should be able to see, where's my point? Oh, what happened here? Oh, I didn't type in B. There you go. So now, because we have calculated this is your R, and this is your angle, this is your X value, this is your Y value, so therefore it's going to show us the point. And we can actually see the formation. And then we can see that after 180, it repeats once again. And notice that this is a negative, so therefore, and I can type in this as 225, which is 5 power 4. Instead of going forward, it went backwards. And then it continues, so it kind of repeats itself. So something to keep in mind is that there's one rotation in here. That's up to pi from 180. And then after 180, equals 6. So you just need to be able to kind of find your, this is a lot of things to understand. You need to be able to find your maximum, your minimum, and then the points in between, and then you just make your shape. And you can use decimals to guide you through the process if you're not too sure what the graph looks like. Now, let's try example number 6. So what is the difference between, take the time to copy it down, you can draw your graph or paste it. So what's the difference between 5 and 6? Yeah, so in this case it's theta and this is 2 theta. Do you guys remember what happens when there's a 2 here? What happens to the graph? Is a vertical stretch, vertical shrink, horizontal stretch, or horizontal shrink? Which one is it? So in this case, yes, it's going to be a horizontal shrink. So now let's go and make a graph. We're going to once again graph the rectangular form y equal, well, in the rectangular plane, the sine of 2x. And once again, it's going to go all the way up to 3 and down to -3. So we need 3 and 3. And once again, I'm going to play 0, 1, 2, 3, 4. That'll be pi. 1, 2, 3, 4 will be 2 pi and 3 pi. Now we are going to find our amplitude. Remember, your amplitude is always positive. It's always absolute value of A. So in this case, your amplitude is 3. Your period is 2 pi over B. In this case, B is 2. So therefore, a full rotation, instead of being 2 pi, is now just pi. So we are going to highlight the first from 0 to pi will be the first rotation. Let me deal with the amplitude first. I'm going to go all the way up to 3, all the way down to -3. And now I'm going to divide this in 4 sections. Half, half, half. Then I need to think, is my sign starts at 0 or at 1? My sign starts at 0. Then I'm going to go all the way up to 3, down 0, down to -3, and back to 0. And I'm going to make a full rotation, make it nice and curved. Now I need to do 2 rotations because we need to go from 0 all the way to 2 pi and not just pi just like we have here. So therefore this will be from 0 to pi. That'll be this part of the graph. And now I'm going to highlight once again another period from 0 to 2 pi. Another pi will be another rotation, half, half, and half. So 0, 3, 0, -3, and 0. And now I can continue doing a full rotation. And now we are going to graph it. So we're going to go through the same process. We're going to find all of our zeros. We're going to find our maximums and our minimums, and we're going to plot them. And then we're going to plot the numbers in between. And we're just going to kind of estimate. I'm not going to be as precise as I did on problem number 5, because in calculus, you actually just want to do a quick sketch and then find the area under the curve. Let's see. We have 0 is 0. What is the highest point? This is pi over 2. So therefore, this is pi over 4. A power of 4 will be 3. So this is pi over 4. Will be 1, 2, 3. Do you guys agree? Now, at pi over 2, which is up here, will be 0. So it's going to go from here, going to go to that point, and then it's going to come back over here. Now, if I want to be able to find between 0 and pi over 4, which is around here, that's the halfway mark. Right? This is 45, so 22.5 will be the halfway mark, or pi over 8, if I want to be precise. And also, if I want to be precise, I can use a calculator. But at this point, we just want to make a look faster sketch. Otherwise, we can just plot point by point by point by point, like we did above or before. And we don't want to do that. We want to do it in a little faster manner, and we want to be able to understand what happens with the graph. So let's see. Here is about 2, well, 2.1 as before, right? So halfway mark is about 2. Then over here, halfway between power 4 and power 2. So on here, it's about 2 as well. So therefore, we are going to go up to power 4, and then we're going to come back, and that'll be a pedal. So what we had before, this section here got moved to this part here. Do you guys see it? So something that you need to kind of understand is that when we went for this rotation here was from 0 to pi. Now it became from 0 to pi over 2. Now let's continue on, and then we'll continue making connections. So now from pi over 2 to pi is going to be negative. So where it used to be here, from this section here, is going to be over here, because we're going to shoot them back. So what is this here? This is 1/4, 2/4, 3/4. So this will be 3 pi over 4. At 3 pi over 4 is going to be, instead of going positive 3, 1, 2, 3, is going to go 1, 2, 3. Then the halfway mark between those two is the halfway mark, which is going to be about 2. So instead of going the halfway mark, instead of being 1, 2, is going to be negative 2. And now you can see that this one will be here. So the halfway mark will be on the opposite side. And then at that point you can say, okay, so therefore it went from here, and now it's going to come back over here. As it got shot backwards. So this is positive, so it's in the correct place. This is negative, so even though it's supposed to be from pi over 2 to pi, it's in the opposite side because it's negative. Now, that was a full rotation. So if you actually go back over here, notice that the first time that I went through is this leaf here, this petal, since this is considered a rose. And that second time that I go over there, because it got squished, it kind of went backwards. Instead of going on this side, it went to the opposite side. So now let's continue with another rotation. With another rotation will be, well now, yeah, another rotation from pi to, what is this location? This is 3 pi over 2. So from pi to 3 pi over 2 is positive. So therefore that means that it's going to be over here. So let's say this is 1/4, 2/4, 3/4, 4/4. This will be 5 pi over 4. So this is 5 pi over 4. And that'll be 1, 2, 3. So it'll be 1, 2, 3. And then at that point you just see, okay, so this will be, that'll be this point here, and that point will be here, because it's symmetrical. So you went from here, I went up, you came back down, you came back this way. And now you're able to see a little better, right? And now it's going to come back over here. So it continues going this way. And now this section here is supposed to be from 3 pi over 2 to 2 pi. But because it's negative, it got shot to the opposite direction. So therefore this is 7 pi over 4, which is here. But because it's negative 3, instead of going towards 7 pi over 4, it goes to the opposite, 1, 2, 3. And now from there I can say, okay, those 2 points are going to be here and here, and you're able to graph a little faster. So therefore it goes over here and finishes up. Oh, I missed it. Actually, it goes from here, right? You can see it from here. Oh, I messed up. No, it's fine. It goes over here. And it goes over here. And then this point comes over here. And don't worry too much about the direction. I'm illustrating it because I want to show you what happens when we do it on decimals. So now I'm going to have it 2 here. And it's a little off. Why is it off? Oh, because I need to have it 2 here. And to make sure that change everything. Now it should be working fine. So, well, okay, so that's not working too well. I'll figure out some other time. So does that make sense? So just by doing the directions, you don't have to place the arrows on your paper like I did here, but that is how it's shaped. Now let's go back. The last example for today. So go ahead and write it down. And I want you guys to start thinking, okay, what is that one going to do to the graph? Go ahead and pause if you need more time. I'm going to make a x and y axis. Once again, I'm going to graph graph on a rectangular plane, just like we've done before on when we graph sines. So what's going to happen to the how is the graph going to get affected by the one? That is the question. So we have. Do you guys decide? Okay. The one is going to move your graph up. It's going to be shifted up one. So therefore, my vertical shift is one. Now remember, whenever it's a vertical shift, it's called vertical shift. When it's a horizontal shift, we call it a phase shift when we graph in sine. Then we have a amplitude of 3, and your period will be 2 pi over b, which is 2 pi over 2, which therefore your period will be pi. And we usually start with your vertical shift. That means that it's going to be shifted up one. So therefore, at 1, I'm going to make a new x-axis. That's where I'm going to be graphing it. Then my amplitude is 3, so I go up 3. 1, 2, 3. Then down 3. 1, oh, it's not 3, it's 2, 3, 4. And down 3, so it'll be 0, 1, and negative 2. My period is pi, so every will be 1, 2, 3, 4 should be fine. Remember, if it's pi over 3, you will make every 3 will be 1 pi. Otherwise, just every 4 will be pi. 1, 2, 3, 4. 1, 2, 3, 4. I'm not going to highlight one period, so it'll be from 0 to pi. And then my other period will be from pi to 2 pi. And remember that you want to be able to graph all the way from 0 to 2 pi. And we usually place that as closed and that's open, so it includes 0, but it doesn't include 2 pi. And now we can graph. We divide in 4 sections, half, half, and half. Sines once again starts at 0, goes up, down, and now a full rotation is here. And now we're going to do continue, half, 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 full rotation. And now I can continue with my pattern and very quick graph. And now we can start graphing it. We can see now what is the highest point. Well, before we do that, how do you compare those two graphs? Now be careful, don't guide yourselves through here versus those two graphs. So notice that's the top. What happens to those two sections? Correct. This one's going to be much longer, right? It goes all the way from 0 all the way to 4. The peaks are in the same location. So the peak is at pi over 4, but it goes all the way up to 3. The peak is, again, pi over 4, but now it's going to go all the way up to 4. And now these two peaks are going to be higher. Now 0 is not pi, which is fine. We don't need to deal with that. Those two sections here, what's going to happen to those two petals? Now remember, those two petals were those two over here. So those are going to get smaller. While those two petals used to be this ones here. Those two petals are going to get longer, correct? So let's just graph it. This is pi over 2. So pi over 2 will be 1, which is fine. The one we consider at the peaks, which is or at 0, will be 1 as well. Then a power 2, a power 4 will be 4. 1, 2, 3, 4. Then at 3 power 4, well, where's this location? This is 3 power 4. Do you guys agree? So therefore, this is 3 pi over 4. It's going to be negative 2. So instead of going forward, it will be 1, 2. Then at pi, we'll be back to 1. Then this peak here goes, the peak or the maximum is going to be, what's this? This is 1 4, 2 4, 3 4, 4 4. This is 5 power 4, which is here. It's going to be positive 4. Then 3 pi over 2 is positive 1. This is pi over 2. 3 pi over 2. This will be 7 power 4 is negative 2. So 7 pi over 4 is negative 2. So therefore, we are going to shoot it backwards. Negative 1, negative 2. And if you want to be able to have a better graphic casino, what happens between 0 and power 4 is about 3. Between 0 and power 4 is about 3. So it's going to go from here, going to go pick up, come back over here. This pedal will be over here. Then there's a pedal going over here. And then there's the one over. Notice it doesn't have to be perfect. So in this case, we're just going to be doing quick sketch. And in calculus, you have to find the area of that pedal. What is the area of that pedal? So now if I change this to a 1 plus, and that is the graph. So now it's a little wider than the ones I have. But for purposes, we just want to be able to do quick sketches that we can actually find, because in calculus, you're going to be able to find, correct? So this is a lesson. Sometimes I go through and try to illustrate the translation between or the transition between this and 2. But it makes it difficult because if I type in an A in here, so as I go from here, from 1 to translation, but hopefully you just need to do a quick sketch. Don't worry about this part. Any questions? Okay. Have a great day, and I'll see you guys next time. Notice my computer is, I need a new laptop. Have a great day.